Welcome to The Explainer. Today, we're unlocking the ultimate survival kit for navigating the high-stakes, high-stress world of DevOps server management. Look, if you're working as a DevOps engineer, or you're aiming to be one, mastering the Linux command line, it's not just a nice-to-have, it is absolutely your primary lifeline.
All right, picture this. You've just clocked in, grabbed your coffee, and bam, the alert hits. Production is crawling. Your apps are completely broken. You've just securely SSH'd into the server. You are the crisis responder right now. But you're staring at a blank terminal. What exactly is your first move? How do you even figure out what to look for?
Okay, let's dive right in. We're going to follow a 6-step structured plan to solve this crisis. Diagnosing system health, managing disks and processes, mastering log analysis, troubleshooting network bottlenecks, securing your server, and finally, scheduling and automation.
Step 1. Diagnosing system health. We need to take the server's pulse.
The absolute first thing you've got to do is get a quick read on the machine's vital signs. Start with uptime. This tells you how many days your server's been running. Why does that matter? Well, if it hasn't been rebooted in a year, there's a really good chance you're missing some critical security patches. Next, you'll want to check free with the H flag to see your memory in human-readable gigabytes. If your swap memory is maxed out, your server is literally starving. Then, check your disk space with DFH. Oh, and here's a massive pro tip for you. Sometimes your disk says it has plenty of space, but you're still getting a disk full error. When that happens, run DFI. This checks your inode utilization. If you've run out of inodes because of millions of tiny hidden files, your disk is effectively completely full. Now, to see what's currently chewing up your CPU, you've probably used the legacy command top. It gives you real-time stats, and you can sort it with keyboard shortcuts. But let's be honest, it can be a visual nightmare. Modern DevOps engineers, we usually reach for htop. It does the same thing, but it's beautifully color-coded and you can actually use your mouse to click and sort. It makes visually tracking down that massive process tree so much easier.
All right, step 2, managing disks and processes. It's time to hunt down the culprit.
We know the server's gasping for air, so we have to track down the specific rogue process and shut it down. This is exactly where the Lego block nature of Linux pipes is just absolute magic. First, run ps-ef to list every running process and its metadata. But that's going to spit out thousands of lines. So step 2, pipe that output into grep, followed by your app's name. That instantly isolates the exact line you need and gives you the PID, the process ID. Finally, step 3, hit it with a kill 9 followed by that PID. That forcefully terminates it, and just like that, the rogue app is dead.
But hey, quick time out. A word of extreme caution while we're talking about destructive commands. Never, ever run rm-rf without a backup. It is irreversible, literally the most dangerous tool in your entire arsenal. If you target the wrong directory, your server's toast and there is no undo button. Always double-check your path, for sure. Moving on to step 3, mastering log analysis, or sifting through the wreckage.
Okay, the immediate fire is out. The bad process is gone. But why did it crash in the first place? It's forensics time, and these commands are your magnifying glass. Use dmag-t to read kernel logs with human-readable timestamps. Did the system kill your process because of an out-of-memory error? This will absolutely tell you. If it's a specific app, journal-catil with the app name and the F flag streams those systemd logs in real time. To find massive, forgotten log files, find is your best friend. You can easily search for files modified over 60 minutes ago. And honestly, my personal favorite? The sed command. Imagine finding a config file with a hard-coded password. Instead of opening it manually, sed can dynamically find and replace that string across the entire file instantly.
Let's say you're staring at a massive log file and you just need a clean summary of what went wrong. Once again, pipelines to the rescue. Start with cat to read the file. Then, pipe it into awk. Awk is incredible for this. By telling it to print $NF, you're grabbing just the final column of every single log line, which is usually the status, like failed or warning. But wait, pipe that into sort to group them together, and then into unique-c to count those unique occurrences. It's amazing. In seconds, you've just summarized thousands of chaotic log lines into one super clean error count.
And when you do find that specific error message, you don't want to fly blind. If you just grep the word error, you only see that single line. Instead, add A2 and B2 to print the 2 lines before and after the match. Throw an I to make it case insensitive, and boom, you have the exact context of what happened right before the crash. It is a total lifesaver.
Step 4. Troubleshooting network bottlenecks. Let's interrogate the traffic. Okay, processes are fine, logs look clean, but the app is still unreachable? It's time to interrogate the network. Now, you might be used to the legacy netstat-tln to check your listening ports, but I highly recommend updating your mental syntax here. The modern tool is SS, especially with the flags TULPN. It's so much faster. It instantly shows open ports, active connections, and crucially, the exact PIDs listening on them. It is the absolute quickest way to verify if your web server is actually listening on port 80 or 443 like it's supposed to.
Let's quickly run through the rest of your network toolkit. NSLookup. Is your domain even resolving to the right IP? If yes, try MTR. It's like a turbocharged traceroute that pings every hop to show you exactly where packet loss is happening along the network path. Need to go deeper? TCP dump captures raw packets for Wireshark analysis. And finally, curl-i. This basically emulates a web browser right from your command line, letting you check those HTTP headers to see if you're getting a healthy 200 OK status.
Step 5. Securing your server. Time to lock down the fortress.
Getting things running is only half your job as a DevOps engineer. You also have to secure the environment against unauthorized access. Let's demystify chmod and Linux file permissions. It breaks down into 3 groups: the user, the group, and others. The math is actually really simple once you see it. 4 is read, 2 is write, and 1 is execute. So running chmod 700 means the user gets 4 plus 2 plus 1, full access. And the 2 zeros mean the group and others get absolutely nothing. It's completely private to you. Oh, and if you ever need to transfer file ownership to someone else, just use the chown command.
But hey, file permissions don't mean a thing if an attacker can just guess your password and log in. By editing your SSHD config file, you can set password authentication to no and permit root login to no. This forces everyone to use secure SSH keys instead of brute forcing a typed password. Seriously, this one configuration change is arguably the most critical step you can take to harden your server.
And finally, step 6, scheduling and automation. Putting maintenance on autopilot. The crisis is averted. The server is healthy, the gates are locked. But true DevOps pros use automation so they don't have to fight this exact same fire tomorrow. You do this by running crontab-e to open the system's task scheduler. Now I know, the syntax looks like gibberish at first, just 5 asterisks. But it's just a secret formula for time: minute, hour, day of the month, and day of the week. So 0, 2, **** literally just translates to run this script at the 0 minute of the second hour, so exactly 2 a.m. every single day of the year. And check out how perfectly these concepts lock together into a workflow. Want automated backups? First, use tar-czf to compress your app directory into a tight archive. Second, drop that exact command into a simple bash script. Third, schedule that script inside your newly learned cron tab. Boom! You just built a hands-free, automated daily backup that runs while you sleep.
So, what's the big takeaway here? You don't just have a list of commands anymore, you have the MVPs of your DevOps toolkit. You know how to monitor health, hunt rogue processes, analyze logs, interrogate the network, lock down security, and automate the whole shebang. So, I'll leave you with this. How are you going to build your next diagnostic pipeline? Fire up a terminal, start experimenting, and take back control of your servers. Keep learning, and we'll catch you on the next explainer.